deliver through your body because the voltage is too low. Oh, oh, come on. This is under something. Oh, shit! Ow! Next something. Damn it! This is a replacement lead of a mechanical pencil. Let's try again. Wow! I'm gonna run 10 amps through a regular pencil's graphite. Wow, this is getting. Oh my god! Whoa! Oh! The graphite gets super hot and burns the wood around it, but it doesn't burn. That's why it's good for high temperature applications. Let's run 10 amps through this graphite and see how much it glows. Look at this! Always wear safety gloves to protect your fingers and don't try this at home. Nice! Am I on fire? You can get carbon rod from a carbon zinc battery. I have my super capacitor bank that can deliver more than 200 amps. Let's make some arcs now. My rods are burning? It seems like there is some flux in them that eventually burns out. Look at that, people. Molten... Oh, This glove is not good for this purpose. There you go. Whoa. Now we can safely plug it in with no problem. Ow! Well, damn it. Well... Plug it in and put it in the... What's burning? Oh no, my wires! Can just plug it under this. Oh, do not attempt this at home, you dummies. We can make some good power resistors from these. Here's a 10 ohm 250 watt resistor that can take 5 amps like a champ, see? Ouch! Now I just need something to wrap it around. Here you go, an almost 15 ohms 300 watts resistor. Let's connect it in series with another hairdryer. Don't try this at home. Let's switch it on. Heating up already. I guess I can cool it down with the hairdryer. How much current is it drawing? Ooh, I'm gonna use my trusty spoon as the potentiometer slider and tune the speed of my hairdryer. The whole thing is fused. I guess we already have our high power resistor with a fan set up here. 10 ohms on 120 volts is like 1440 watts. Just use a hairdryer as your power resistor. It has multiple resistor settings, a cooling fan, and all the safety features already set up, while you can use it to dry your hair. If there was any. We all know what a switch is. What I'm trying to say is MOSFET is basically a switch. So for example, let's make something. I use an N-channel MOSFET to turn on a light bulb on 120 volts AC, connecting the gate to a 10 volts DC. There we are. Different MOSFETs have different voltage ratings, so we pick one that can do 500 volts. We turn it on. For the love of... MOSFET has a maximum current rating above which it overheats and burns. We are in a good shape with a high voltage, high current transistor. Honor? I'm pretty sure I connected everything. That stupid body diode in my setup is what's conducting in the negative cycle of the AC. We rectified the AC first. Full bridge rectifier connected. Let's turn on the gate. It's working! Electrolytic capacitors can blow with a... But they don't always blow up. I want to see what happens to them when they half break. I have a tiny electrolytic capacitor and I'll half break it by connecting 120 volt AC across it. Don't try this experiment. Total failure. When I say half failure, I mean the capacitor is capacitating at half its capacity. My capacitor is rated for 16 volts, but I place it in reverse polarity. It's almost 1 watt through the capacitor. The issue with tiny capacitors is they don't have pressure release mechanisms, but the bigger power capacitors have it. For example, these tiny grooves on the top plate. So when I overload the capacitor and it bulges, those tiny grooves on the top break open, allowing the release of the... Stop it. The capacitance now is only around 420 microfarad, dropped way down from the original 2200 microfarad. Current kills not voltage. This 12-volt battery can deliver tens of amps of current if I short its output with this piece of wire. Ouch! But it won't deliver through your body because the voltage is too low. I guess don't eat the battery. I'm pretty sure it should go on fire. Oh no! Jeez. Now we connect the live wire and we can start welding. Ow! With the Tesla coil on, it won't cause an explosion. Let's plug it in. Stop putting your hand in front of a magnetron.
Electrostatic discharge, or ESD, is an electrical charge that is stored in something like human body and can jump to devices like laptops and cell phones and damage them. What they use for testing is something called an ESD simulator or a gun. Here is a 25 kilovolt discharge. The tip of the gun here simulates a human finger. Always be careful with your tools. Sometimes it's also beneficial to zap a bare board like this one and see what happens on the actual board. Never hold the board you're zapping with your hand because the ESD will jump to your body through the board. Now this board is connected to ground with this wire, so if I try to zap it, it will continuously discharge. But if I disconnect the ground wire, it will only jump a few times. Because now the board is charged to the same level as the gun and it doesn't jump anymore. Always discharge the charged board before touching it.
Do you know what happens when we throw an LED light into a cup of water, pour some salt, mix it well, and put in the... This is a dangerous experiment with live wires. Don't try this at home. If we place the live wires in the water, the LED turns on. This is because the impurity in the water makes it conductive and some of that electricity runs through the LED, turning it on. So if you threw an LED in the water and it turned on, don't swim in that water.
Today I'm going to talk about building a gun. The gun I'm going to talk about runs purely on electricity. So here's the coil I made and a steel bullet. If I put a steel bullet inside the coil and try to turn it on with my power supply here, well, it's always safer not to work with live loose wire, so instead I'm using these alligator clips here. There you go, you saw what happened. Always make sure the wire gauge can handle the high current.
Here's the schematic of the circuit I made.
I put the circuit together and I'm gonna shoot the box, and there's a switch here that acts like a trigger. So here we go. It's always wise to aim away from yourself. Put the bullet in.
Wow! How do you measure high voltage? Of course, we can probe the voltage. Check your setup before committing to something. The simplest way is to divide the voltage down below what your measurement device can handle. A resistor divider is the way to go. If we can measure the... Oh no! Only consume power below their power rating. These 100K, 1K resistors should be good though. There you go. With these values, they remain cool. It is always advised not to touch live high voltage. Same divider trick can be used to measure very high voltages like on my Van de Graaff generator. And 0 volts, it's impossible. I can use my man-made driver which can maintain a much more powerful output. So I'm using a 10 mega ohm and a 10 kilo ohm resistor to divide the voltage by almost 1,000. We turn it on and... So I have a 2 giga ohm resistor here that I connected to a 2 mega ohm resistor for an almost 1000 to 1 division ratio. So we just turn it on. Let's reduce the supply voltage. How about now? How about now? Okay. So we are measuring above 9,000 volts. I have a ballast. ballast. Basically, the way the ballast works is that first you tie its input. Ow! Always wire up before powering your circuit, so you should be able to turn it on. Electric tape is your friend. Just cover all the exposed wires. How does this ballast work? Why is the fuse broken? To short it now. Why the fuse went to start with? Oh, Let's just find a ballast. Ballast. Hey! I just connected my powerful ballast to my puny CFL bulb, and hopefully it will blow up magnificently, make my heart a little bit happier. Let's see. It just turned on. You might be thinking that electric heaters dry the air more than other types of heaters, and you would be wrong. Just to be clear, an electric heater is just a resistive piece of wire that heats up when electricity passes through. I have also heard this argument that maybe electrolysis breaks the water molecules into oxygen and hydrogen. Really? If you recall, for electrolysis we need a continuous body of water and two electrodes with high enough voltage difference to break the water molecule. Well, maybe not a voltage that high. You get it? Stop dragging electricity's name through the mud. It's okay, darling. They apologize. Why is this still plugged in? I'm going to show you how to design a taser. By no means is this safe to be used on any living creature. For my transformer, I use this one that's generally used in a car. Here I connected a power cable to the primary to connect it to the wall plug. I'll plug it in. This transformer is obviously not made for the 60 Hz city power frequency. If I connect my 12 volt supply here to the primary and charge it and then disconnect it, the voltage of the primary should jump up, creating a huge voltage on the secondary here that should create a spark. Let's try it out. Is there actually a voltage? Well, my theory was right. I put this capacitor bank together and put it across the primary. Let's pulse the primary now. Look at that, I have sparks. Now I need to make the sparks continuous, so they go zzz. I've made my simple circuit here and I attach it to the primary. Let's try it out. You can see how far. This gap is quite wide. Let me measure it for you. And convert the energy into heat. Ow! A capacitor stores energy in form of electric fields between electric charges and can later release them when a load is connected between. Inductors store energy in the form of magnetic fields. Oh And yeah, I guess every wire has a resistance too. As you know, a speaker is a magnet and a coil that when you excite the coil with an AC voltage, it vibrates at the same frequency. And that's why they say a capacitor blocks DC, but an inductor blocks AC. Let me demonstrate. If I plug it into the plug, is there actually a voltage? I make this simple circuit and I'll plug it in. Now the circuit is hot and the voltage is on the. Now I have replaced the capacitor on my circuit and I'll plug it in. Now I enable the power supply. Go! Go! Shear lock! And we can easily connect them together. Then we unscrew the outlet and pull it out. Ow! Ouch!